Well, hello everyone. Welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look at this thing. It's a Soroc IQ 120 terminal. And I know very little about this thing other than it's extremely heavy and it's probably from either the late 70s, but more likely sometime in the early 80s. Since I've had this thing, I've never tried to turn it on or even open it up. So really, when we look at this thing, we're going to be looking at it together for the very first time. And I want to try to learn a little bit more about this thing, the brand Soroc. I've never even heard of it. See what we can figure out, and then see if I can actually get this thing working. So without further ado, let's get right to it. Thanks to Al over at BitSavers, some information has been preserved about the Soroc IQ 120, which is what we're looking at here today, and a little bit more about Soroc Technologies, because I couldn't find much else out there on the internet. It seems that Soroc Technology Incorporated was a spin-off from Lear Siegler and was created as a separate company in mid-1975. And prior to the introduction of its initial product, which is the IQ 120 we're looking at here, they performed contract engineering for other vendors. And I guess they designed the B5 B100 terminal, which when you look at the B100, it's not that dissimilar to what we're looking at here with the IQ 120. Looks like the IQ 120 though is a teletype compatible glass teleprinter and uses Lear Siegler compatible code structure, whatever that means. The IQ 120 was released in November 1976, and at least at the publication of this document, whenever this came out, 3,000 were delivered to customers. The IQ 120 was supposed to be a low-cost teletype compatible keyboard display terminal with baud rates from 75 up to 19,200 bits per second. And the purchase price was between $995 and $1,095. Also available on BitSavers is the operation manual, and even better than that, the theory of operation manual, which as you can see here, includes the schematics. That is excellent. Now, I'd just like to throw out the caveat that I'm recording this footage here of looking at these documents after I've already gone in and taken a look at this terminal in depth. It's kind of something I like to do. You don't always have documentation available for you to look at when you're looking at something new like this. So it's good to practice your skills of trying to figure out how things work from a high level without using the documentation. Once I've done a lay of the land and kind of figured things out of the terminal, then of course, if the documentation exists like this, absolutely go ahead and use it to help you, well, shortcut some of the reverse engineering and trying to figure out the way things work, especially if you're dealing with faults. So with all that said, let's take a closer look at the IQ 120. From an industrial design standpoint, I really do like the way this thing looks. The centered CRT, the big chunky keyboard here, which I hope is not foam and foil, because I really don't feel like doing a foam and foil keyboard right now. Hopefully this is some other mechanism that hopefully actually works. You might have noticed in the intro that the CRT is looking, well, let's just say worse for wear. What we have going on here is what we refer to in the industry, like as if I'm in the industry, as cataracts. What's going on here is that on top of the front of the CRT, there's actually a safety lens. It's another piece of glass that's been applied. And between that and the CRT itself is a layer of transparent glue. Well, over time, due to whatever chemical breakdown happens, it starts to degrade. And you know, it looks really, really bad. Now, some of the things that can happen with this is it can start to ooze out and leak down onto the PCB. Hopefully that's not the case here, because that might have just totally destroyed the main circuit board, especially if it goes under this part of the CRT here. This type of thing is pretty common with old CRTs, especially the ones with round picture tubes, also known as roundies. And there are ways to actually separate the front glass from the CRT itself. You have to kind of cut through this glue, clean it all off, and then you can re-adhere the safety glass on top using some silicone sealant around the edges, and that sort of gets rid of this, well, this disaster that we have here. Now, if you're wondering about the safety glass, the reason why that it's been applied to some CRTs is that they lack this metal band right here, which is also known as the implosion band. If you notice, the front of the CRT has a slight curvature to it. So you can imagine if the front glass tried to implode, well, because it's curved, it would need to expand slightly to cave in, basically. And remember, there's a vacuum inside of here. Well, this strong metal band that's applied around the edge of the CRT prevents this part of the CRT from expanding, which helps protect the user from injury. If the front were to implode, you would get a whole bunch of glass all over the place and it would be really bad. So removing this band from a CRT like this is really not a good idea. And on a CRT like on the IQ120 here, the safety glass that's on top of it is actually doing the same protection as that implosion band. So most likely if we take this thing apart, we're not going to see an implosion band around the picture tube. Therefore, if something were to strike the front glass, potentially there could be an implosion. So a lot of times the CRT underneath this might actually be good. And if we get this thing powered up and working, we should be able to see some text displayed through this disaster here. Although the glue has degraded so badly here, we'll probably struggle to read anything on the CRT. Now looking at the keyboard here, we have a somewhat conventional layout for the time. There's a quotation mark there instead of next to the enter key. And in fact, I'm noticing over on the right side here, the return key is there as opposed to on this row. Oh, look, the escape key is over here as well. So slightly unusual. This thing does have a numeric keypad with some arrow keys over here in a row. Otherwise, the keypad there is somewhat conventional. Now, the weight of this thing, it's extreme. This thing is so unbelievably heavy. And one of the things about it is the rubber feet that were probably on the bottom, on the front side here, have come off. So when you put this thing down onto a desk, well, you can't even get your fingers underneath it to pick it up. And it's really, really stout, let's just say. Side of the terminal is just a big blank slate, and the top here as well is nothing going on, no vents or anything. Because I think if we turn this around, and I have a towel, the 70s towel on the bench here to make sliding this actually possible, we have a large fan, probably 120 volts. This has a fixed power cord, it is grounded, large power switch, some kind of a fuse or circuit breaker. And then we have the inputs and switches. So here's an aux port, main port, which we can assume is RS-232. There's a printer port that's not populated here. There was a rotary selector here for the baud rate. It was set to 13, and I haven't touched this, so this is how it was when I got it. We have two potentiometers here for contrast and brightness. And these I don't think are missing knobs. I think this is the way they are. They are slick, they're not keyed, and I don't see any marks from a set screw from knobs that would have been installed on here. They do still turn contrast and brightness, so that's good. They're not frozen. And over on the far side, this switch here says HBF, whatever that stands for, I don't know. It's 3 settings, it was set to F. And then there's area for another switch that's not installed, CLRS, whatever that is. We have some labeling up here, Soroc Technologies Incorporated 165 Freedom Avenue, I guess, Anaheim, California, 92801. So Southern California, near Disneyland. There's a serial number and it says 1 amp, 60 hertz, 115 volts. Judging by the weight of this thing, I'm assuming we have a large transformer in here as part of the power supply. Now, I was sort of curious to look on the underside of this. Incidentally, we have a screw here and there's one on the side, so probably 2 on the other side, and that probably removes the top cover. I wanted to flip this onto its side here so we can see if we see anything. Okay, we just have a big solid metal bottom. This is under the keyboard. There are some bolts there, and there are some holes along the front edge here, which, sorry, you can't see. If I turn this, let's see if I can get this turned. Moving this thing around is kind of heavy. There we go. Now you can see these holes here, which are obviously vent intakes for the fan. And I can feel a PCB down there, and then metal shielding between the card cage or whatever, where the PCB is and the CRT section of the monitor. And I can see a little bit of a ribbon cable right through here, and maybe that's the connection up to the keyboard. All right, well, first things first. It's time to take the cover off, right? We got to get inside of this thing and take a look at what we see. Incidentally, the one above the fan was longer than the rest. Okay. Okay, here we go. Nice. Careful for the back, the neck of the CRT. Let's see what we see in here. Ah, fiberglass. Okay, so handmade, I guess. That's pretty awesome. Okay, well, starting with the CRT, but you can see that well, it's looking kind of gross here. This is that stuff I was talking about. Oh, it's just falling apart. Generally, the way you get this off is you put the CRT out in the sun in the summer, and it really heats up the front surface. And then you could use a wire, say like a guitar string, to saw through that, and then you can kind of scrape and clean it all away, and then reapply the safety glass. The problem for me right now is it's December, it's not summertime, and there's no heat to be found outside here in the Pacific Northwest this time of year. So there's no real way for me to service this. So I think if this thing can work, I just need to swap this entire CRT out. Now it does bring up the question of the spacing here between the screw and the front of the safety glass. And if I put a regular CRT in here, there's going to be a gap between that bezel on the fiberglass lid. But if we take the CRT that I had sitting there and we just sort of compare it, yeah, so this CRT I'm holding above the terminal is the same as the one that's in here. So I could swap this in and it would work. But then we just have that gap and it's gonna look kind of ugly. Okay, back to the keyboard here. I was worried it was a Keytronic, but I don't see Keytronic written on here anywhere. In fact, on the PCB right there, it says Soroc. So they designed this keyboard themselves, and I guess they bought these key switch modules from a company and they are inserted into the PCB. Let me try to remove one of these keycaps here now that I have good access. Ah, okay. Well, what we're dealing with here is a stack pull switch. And you can tell because there's this square thing going on. And when you push this down, it actually pushes a little contact in this slider here that makes contact between these little metal tongs or forks or something that are in here. I don't know what the right terminology is. Luckily, they are reliable in that they work. The problem starts to happen though is I think it's either this like starts to crack, or maybe it's this part here, the slider starts to crack, just under stress of use and stuff like that. TRS-80 Model 1s and a bunch of other old retro computers use this exact key switch type, but it is more reliable than foam and foil when it comes to longevity, so there's a good chance that this keyboard is just gonna work perfectly. Or, you know, maybe it will need some cleaning. You can just clean these contacts here with a little contact cleaner and you should be good to go. So we'll just slide this switch back on. So that is back on. Doesn't feel super great to type on, which is just indicative of these stack pull switches. They're just a little kind of crunchy. Just the dirt goes into the slider and stuff. It's just not a sealed design, so it doesn't keep out the dust that well. All right, so keyboard and CRT, we know what we're dealing with here. Let's turn this thing around. I can see the giant transformer. Wow, this is horrible. It really feels like this, the stuff they put in between the glass like leaked down. Look at the label, it's all horrible there. Which may, I don't know if it's conductive or corrosive. It might have done bad things to the deflection yoke. Anyhow, as suspected, we have a giant power transformer here. So yes, linear power supply. In fact, the voltage regulator, I can see it's under the CRT there. We have a large capacitor here, which is kind of wobbly. It's hopefully okay. It's sort of tilted over towards the back of the computer. Maybe this thing was dropped. I don't quite know. And you can see the top of another cap here, plus another heat sinked, or a few heat sink things. These might be related to the CRT, like vertical, horizontal drive, something like that. We do have some potentiometers down here. I see rectifiers, or diodes that is, so maybe that's the bridge rectifier for the mains AC. Down here, you can see the corner of the PCB for this unit, and it's pretty large. It's all the way to the back here, and it looks like it probably goes all the way to the front as well with this multi-pin Molex, plus these two capacitors here. These purple wires here, these come directly from the power transformer. There are green and blue wires that do make their way down to the main board here. This large heatsink here on the main board, this is for 5 volts. Which would be the biggest draw, right? Because there's so many TTL chips on this thing. And the purple wires here might be for the minus rails. RS-232, which is certainly what this thing is using here, will use those minus rails. Turning our attention back to the CRT again, I'm going to say this thing was well used. There is a lot of gunk on this. Now this could be from that stuff leaking out, I don't know, but it's gooey and really gross. Anyhow, you notice here the flyback transformer is on its own, mounted on a little board. That's pretty cool. And this right here is the high voltage diode, because this is a transformer, so it outputs AC, but the CRT is a big capacitor and needs DC. So normally on newer flybacks, that's internal, but here it is on the wire. I think it may be hard to see, but I'm poking on a connector here that almost certainly carries the video signal to the CRT board from the motherboard. And it's these thin wires right here. This seems to be a pretty standard thing across these machines from the late 70s, early 80s. I'm no expert at this, but it seems like, from my understanding, this CRT top part here could be sold as an individual module that was sort of a chassis mount CRT, and you could buy that and put it into your computer and then plug that cable in. It'd be somewhat standard. Obviously, if you're using, say, 60 hertz, 15 kilohertz, normal NTSC, those monitors were very, very plentiful, and it would be very easy to just buy one of those CRT modules, and they were all sort of standard spacing. Screw that in, connect the connector up, and you're off to the races. Computers like the TRS-80 Model 3, Model 4, the TRS-80 Model 2, I think, uses that same connector. I've just seen that on all sorts of stuff from around that early 80s time period and before. I don't think that's quite the case here, because we obviously have some kind of regulation going on, I think, for the 5 volts. And I say that again because you wouldn't have a huge cap like this on any CRT board. So they must have custom designed this thing for themselves, but they still ended up using that somewhat standard looking connector, at least. I don't know if the pinout is standardized, but it seems to be what they did. I'm looking at the date code on the large transistor type package in the middle, and it's 7940 first week. So it kind of dates this thing. Something that's super concerning is it's like the goop that came out of the front of the CRT has made its way all the way down to here. Concerning because it's gone underneath the deflection yoke, and if this thing is damaged in any way, then that pretty much, it's going to make it very hard to get this thing working again. Kind of curious is these connectors here. They don't have anything to keep them connected to the board. They just pull out. It's just friction fit. But they were still attached after all this time, so I guess that's okay. I see a 7912 right here. That's a minus 12 volt regulator, because there's a bridge rectifier here and that voltage regulator. And again, looking at these wires here, the 2 purple wires here, which are the same color, they go right to the transformer. And out of the transformer comes 2 blue and 2 green wires, and those go to this upper PCB over by the diodes and that large capacitor. And then it looks like this purple with stripe also goes to the transformer. But then these 2 wires right here, white and black, they make their way over to the main board there. And down there, you can just see it. It says 5 volts, and it's these 2 wires right here. So this may be the output of this thing right here, which is what's generating the 5 volts for the motherboard. Pretty thin wires for that, though. So there's a few things that I'm concerned about with this design of this. First off is this capacitor here. It's kind of wobbly. I'd like to, yeah, it looks like there was some hot glue maybe there that's come off. I'd like to try to reform this capacitor. And I'm thinking the way to do that is there are some discrete diodes right here, and one of those should go to the negative and one should go to the positive on this. So theoretically, I could clip onto those and I could start to bring this thing up to voltage just ever so slowly. That would kind of reform it. What I don't immediately see looking at the design of this is, how do I gain access to the bottom of the PCB here that's under the monitor? This all seems to be riveted together here. I'm thinking that maybe once we have access to the PCB on the underside, then there's a way to unbolt this top thing, and then we'll gain access to maybe the bottom of the PCB here. I say once again, I'm getting ahead of myself. So what I'm going to do is I'm going to try to turn this thing up onto its side. So it looks like, well, there were 4 feet here. Someone tried to put this Blackfoot here. There's another one there, and then these 2. Don't know if these are even the right ones. They have to be pretty tall to clear these plastic standoffs, for instance, that are on the bottom. But looking at the bottom here, there are some bolts here, some fasteners that should release this bottom plate, which I think should give us access to the PCB. And okay, looks like you have to tilt this forward and that way because there are the controls on the back for contrast and the ports and stuff like that. So I'm going to take this fastener out because the metal is sitting on the desk there, so that's not going to go anywhere. And then there's just this one, but I just realized the keyboard is still connected. So I'm going to try to pull that out. Actually, I think there's enough slack on the cable. So I should be able to, let's see, I need to prop something underneath here so it holds this up. There we go. When I get this fastener out, I don't want it to fall down. Now the funny thing is this is actually removable with the top cover on. So you could flip this thing upside down and then potentially try to get the PCB out. Okay, so like I said, yep, there we go. And there's the keyboard connection. I think it's out of focus. I apologize. There it is. It was pulled out a little bit. I didn't do that. So you should be able to just get this out like so, and it's free. All right, there it is. There's the PCB. Look at the size of it. Remember, this is a terminal. This doesn't do anything. Well, I don't think it does anything except display text from an attached mainframe or computer like an Altair or something else that didn't have a built-in display. Now, what's this? That's just dust. So I can document the way this thing is configured. These switches here are all set to this up position or down. I don't know. The little sticky out parts are on the top. Here in this section of the board, we obviously have some RAM, and it says 2102 right there, and that's exactly what's installed on this board. I don't remember off the top of my head what size RAM this is, but the date codes on all this stuff is 5th week of 1979. This large 40-pin package here, it is a 1602 TR1602-B from 1978. I can't see right here though, these two ICs are Motorola 1489 and 1488. And you should recognize these. These are used all over the place on these older systems, and these are the serial port transceivers. So essentially they're converting from the TTL signaling that's happening on the main board here over to the RS-232 signaling for the main port. And then we have another two of them right here for the aux port, which would be like hooking up, I don't know what you'd plug into that, probably a serial printer. So you could print from the main system through to a printer here. And then this printer port that's not populated potentially probably has a little board that plugs in right there. Maybe that's Centronics. And looking around the board, the only voltage regulator I see is the 7912, and there's a bridge rectifier that goes with it right there. So I would have to assume then that there's going to be 12 volts DC coming in on this connector here, plus 5 volts. And using continuity mode on the multimeter, we should be able to figure out exactly which pin here is going to 5 volts. The black wire that's on this connector, which goes to this pin right here, pin 2, that's the 5-volt rail. It's found right there. And it's the white wire which goes to this pin here, which is 6, pin 6. That is the ground. And you can find it on this capacitor right here. All these capacitors here are on the ground pin, and I guess they're probably on the 5-volt pin as well. Yep, 5 volts, 5 volts, 5 volts. And then that kind of has me thinking that this larger connector here, this thing which delivers the video signal, maybe also carries 12 volts from that main PCB for driving the CRT down to this board for going, for instance, to the serial port. These caps right here are almost certainly used for the bulk capacitance for this regulator here, so this minus 12 volt rail. Okay, with this meter, you have to make sure that the cap is fully discharged before you measure it. Just plugging the leads in together. Yeah, 1054 with an ESR of 0.18. I mean, that seems fine. Okay, I don't know, I was worried about these caps when I don't think there's anything to really worry about. Seems fine. All right, let's measure this other cap here. I have the leads reversed and they are connected together still, just to make sure it was discharged. Plug this in. Same, 0.23 ohms, 993 microfarads. We're at 1 kilohertz right now. We can obviously change the frequency. 10 kilohertz is going to read lower, 126. But yeah, these big caps, the higher frequency doesn't really work with those. They are generally handling 100 hertz though, and 186 microfarads, 0.3 ohms. They seem fine. Maybe the ESR is slightly high, but I don't think there's anything wrong with these. Okay, well these caps seem good. I'm thinking that all these other smaller caps are fine. I'm just gonna give these socketed ICs, there aren't that many of them, a little bit of a push, just in case they're kind of loose on the board. All right, and I'm gonna move this so we can look at the CRT situation. Looks like you can loosen these fasteners and slide the CRT module forward to try to potentially get that disconnected from this chassis to gain access to that large capacitor that was on here. So I'm looking to disconnect everything on the CRT from everything else that's on the bottom chassis. So this cable here and that connector that goes down to the motherboard, it slides on. I know you can't see what I'm doing, my hands are in the way, but it is disconnected now. And the final one is this wire right here, the 5-volt rail that comes from the monitor PCB. There we go. Right, so that's it. All I need to do now is loosen those fasteners. Wait, you know what? These fasteners, the CRT module it can slide forwards and backwards. So that means if I replace the CRT with something else, I can move it all forward to fill in the gap if we don't have that safety glass. All right, it's almost like they knew they would have some CRTs with the glass and some without. All right, so getting these off is gonna be tricky. I need to do it in a way that this whole thing won't just fall apart here. I don't know how I'm gonna do this. Okay, so that one's loose. I think what I'm gonna do is I'm gonna put this down on the bench and I'm gonna take this out by hand here. And that should free the unit. There it is, there's that screw. Is this thing loose? Oh yeah, it is. Okay, cool. There it is. Ah, look everyone. That is corrosion. That's corrosion from that front glue. It's come down on here and it has sort of made a mess. It's a good thing that we did not have the PCB right there or it would have just been killed. And yep, look at this. The goop's all over the bottom too. This is so gross. So it kind of tells you if you have a CRT that's got this cataracts, you really need to deal with it. Now, the good thing is this thing's upside down here. As I can see, there are clips here. I can pop these out and the whole PCB should come out and give us access to that capacitor. So these clips, oh yeah, the PCB just sort of falls down. So we'll just squeeze these. Okay, so this is loose now. And oh dear, this is not good. We've had some kind of fireball here, haven't we? Oh, darn. That's terrible, terrible. And really, I'm just trying to make heads or tails of this. The transformer, well, it's delivering, you know, probably 15 volts AC or something like that. So why did this happen? How did this happen? You normally get this with high voltage. Part of me has me wondering now, maybe there's something failed inside the transformer or some other part of this board and somehow some very high voltages have made its way to this. Something weird and catastrophic has happened here and this doesn't really make sense to me. No part of me would have expected to see this blast damage under here. The only thing I could think of is that this maybe was running and it got pushed up against the metal here. There was a standoff right here. That's the hole for the standoff. You can see how it's clean there because the little plastic standoff, which incidentally, here it is right here, was sort of covering that part of the PCB. But look at this. This is just, the PCB here is completely gone. All right, I'm just gonna spend a moment to try to get the rest of this board out from this chassis so we can look at the whole thing. All right, here's the PCB. Everything looks fine except for this one horrible area up here. As far as this big cap goes, it's marked 3,300 microfarad, or sorry, 30,000 microfarads, 20 volts DC. L cap is the brand, EL space CAP. Well, we might just have to kind of abandon the 5 volts regulation part of this board. So this board is made up of a couple areas here. This is the connector here that goes to the transformer. Remember, there were 2 sets of leads, and I have a feeling that one set would be for the 5-volt circuit, and I can see these pins go up to this area, but the other ones make their way to here, and there's another bridge rectifier and another cap right there. And I have a feeling this is the 12-volt circuit. Notice these 2 screws here. This is another regulator, and it is a 7815. So we have a 15-volt regulator right here. And I have a feeling that is powering up the CRT. But one thing we can probably do here is replace all of this stuff with a 5-volt switch mode power supply and a 15-volt one, or maybe a dual rail 15 and 5 volts. I might have one of those in stock. And just feed the 15 volts where this regulator is, which should power up the monitor, and then feed 5 volts where this is, and that will power up the motherboard and stuff. And we can eliminate this blown up cap here and the rectifier that's there on the board. And it's kind of my assumption, oh gosh, there's that goop from the front of the CRT all over the wires here. This thing's a mess. It really is a mess. Right, so that was unexpected. I kind of thought this video would just be me swapping out the CRT, because I knew that was bad, and then powering this thing up and seeing if it worked. I didn't realize the power supply would be kind of blown up this way. So I need to come up with a plan on what to do next with this thing. And I really think that that's going to involve probably just replacing the whole 5-volt circuit with a switch mode power supply and just doing away with that whole big transformer and stuff like that. We know that there's a 15-volt regulator right here. So I need to look if I have a 15-volt switch mode power supply that I can replace this regulator with. And then hopefully that'll take care of the CRT, and maybe if somehow 12 volts makes its way from this board down to the main board. Question is, what caused this blast damage? This makes no sense. We can pretty much be sure, because this cap was, I think, a 20-volt cap, that this whole area was getting less than 20 volts. So what caused this? How does less than 20 volts cause this damage here? And there is a circuit breaker on the back of the case sitting over there. And it didn't blow, I guess, when this happened. I mean, there's a whole section of the fiberglass here that's kind of blown off right there. It's just, I could see the weave. So I think on that cliffhanger of sorts, I'm going to end this video here. If you have experience working on these kinds of linear supplies and you've seen this kind of blast damage, I'd love to hear about it. What do you think caused this? And then also, should I just try to scrub this, clean it up, put a new cap in place? Or maybe this cap works for all we know, actually, and go from there? Or should I do the conversion to switch mode power supplies like I mentioned? It would certainly make the whole thing a whole lot lighter. So in the next video, I hope to sort out the power supply situation and get to powering this thing up. See if the CRT board works or if there's a fault. Obviously swap that CRT if we can get the system working, and then see if the digital board, which is down here, and it's quite heavy on its board, is working properly or not. So there we go. I hope you enjoyed this video. Thumbs up if you did. Subscribe if you haven't already subscribed. Huge thanks to my supporters. Their names are going up beside the screen. They make it possible to do this full time. It's YouTube memberships and Patreons, both available for you if you want to become a supporter. They really do make it possible I do this full time. If it wasn't for them, I wouldn't be able to do it. So yeah, thanks again. And like I mentioned, if you have any ideas, definitely comment down below. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.